Okay, I want to talk about the domains of log functions and how that argument is really what's impacted by the domain. So this guy right here is your, and this value, this log graph here crosses at 1, 0. And it has a vertical asymptote at x is 0. And this value here has to produce a positive argument here. So for whatever values of x you substitute in here, the argument has to be positive or that function doesn't exist there. So in order for that to be positive, well, first of all, if I set x greater than 0, x is going to be 0. If you were thinking about solving that, so all the positive numbers, that's what values greater than 0 are. So every positive value that I substitute in here will work. So let's just think about this. Let's say I have log base 2, and I put in a -1. If I take this, 2 to the power of y equals -1. When you have an exponential function, this is what your exponential function looks like. And your range of an exponential function are values 0 to infinity. You have a horizontal asymptote at y is 0. So my range is talking about my output values. My output values go from 0 to infinity. So I can't get a value that's going to give me an output of -1. There's no value that will output -1 because -1 is down here. And my range is from 0 to infinity. So I can't have any values that produce a negative value there. Then negative output. My outputs are 0 to infinity. So again, if I have 0, if I put 0 into this, 2 to what power will give you 0? Well, nothing will. Because again, I go from 0 to infinity, but I'm not including 0. Again, this is that y, that horizontal asymptote. I'm creeping to 0, but I'm never actually going to touch 0. So because my outputs go from 0 to infinity for the exponential graph, that's why my log function's domain are all the positive values. Because again, think about it. These equations here are inverses of each other. These equations are inverse functions. So the domain of an exponential function is all real numbers. I can input anything I want, and I'm going to get a value in return. My range, though, my output values, again, were 0 to infinity, positive infinity. My domain of a log function, they switch. These guys flip-flop. My domain is now from 0 to infinity, and my range is now all real numbers. So again, domain are your inputs, range are your outputs. Domain are your inputs, range are your outputs. So let's think about this. If I take another graph, let's say we take y equals log base 2 of x plus 3. This argument, this is what I'm worried about. And this guy here takes your log graph and shifts it left 3. Well, when it does that, that's what's actually creating your your vertical asymptote. If I set x plus 3 equal to 0, x is equal to -3. That's my vertical asymptote. That means my graph comes along and it snakes this way. That means I can only input values that are bigger than -3. My argument has to be positive. Think about it. X plus 3. I need to pick a number bigger than -3. Well, let's pick a number that's smaller than -3, which is -4. -4 plus 3 would make the argument negative. I cannot have a negative argument. Let's pick 0. 0 plus 3. That makes that 3. That's positive, and that's okay. 0 is greater than -3. Let's pick 4. 4 plus 3 is 7. 7 is bigger than -3. So every value bigger than x will produce a positive argument. Now, let's say I have y equals log base 2 of x squared. I need my argument to be positive. So think about some numbers. I really think you only have positive or negative numbers. If you take any negative number and square it, you're going to get a positive number. If you take any positive number and square it, you're going to get a positive number. All right, so my positives work. Now, what if you put 0 in? Log base 2, 0 squared. 0 squared is 0. So again, think about it this way. 2 to what power gives you 0? That's an exponential function. Nothing will give you 0. It has that horizontal asymptote. It never crosses the x-axis. So give another one. Y equals log base 2 of x cubed. Let's think about positive and negative numbers again. First of all, 0 will not work. Sorry, let's go back up to this guy. It literally is everything except 0 that's going to work there. This guy, x cubed, let's take a negative number. If I take a negative number and I cube it, that gives me a negative value. I can't have that. I can't have a negative value. 0 cubed is 0. I can't have it. I could take any positive number, though, and cube it. I can take any positive number and cube it. So my domain for this guy would be the positive numbers, or the positive numbers. But again, I can't have 0. So when I'm doing this every single time, I'm thinking about the very specific function that's in the place of this argument. And that's all I'm really doing, but I have to understand previous equations in order to do that. Let's go for another one. We'll go y equals, let's say, log base 4 of 5 minus x. All right, this guy, this is the argument. This is what I'm focused on. Well, 5 minus x equals 0. X is going to equal 5 there. So I know that that's going to play into it. Now I have to be very careful about this graph and the behavior of that graph. And so what we're going to do is we're going to actually turn this into exponential functions, and we're going to see how this exponential function appears. So we're going to get into the inverses tomorrow. When you have these kind of wacky graphs that have some different transformations in them. Let's take a look at this guy. Y equals, these are our favorite, log base 2 of x minus 5 over x plus 1. My argument has to be positive. I know this is still kind of a hard concept to understand, but the only time that this is going to work, if I cross multiply this, again, I solve this really as an equal sign. When I have an inequality, I want positive values so it's greater than 0, but now it's an inequality, I solve it as equal. The only time that a fraction is equal to 0 is when the numerator equals 0. I'm not just selectively picking the numerator. X minus 5 has to equal 0, x has to equal 5. Now, we just spent a whole unit talking about inequalities of rational functions, and we based them on our asymptote. That was our vertical asymptote, and we based it on our solution. And we took values and we substituted it in. So I have negative infinity to negative 1, I have negative 1 to 5, and I have 5 to infinity. So I can substitute in a negative 2 minus 5, negative 2 plus 1. Negative 7 over negative 1 is a positive 7. 7 is greater than 0. That guy's true. 0. 0 minus 5 over 0 plus 1. That's negative 5. Negative 5 is not greater than 0. Let's go 6. 6 minus 5 over 6 plus 1. That's 1 over 7. And I know some of you really get stuck on fractions, but that's a positive number. Positive numbers are bigger than 0. That guy's true. So my solution that would make this log graph work is negative infinity to negative 1 union 5 to infinity. So this is putting together everything that we've done so far. You are responsible for every function, their behavior, what they look like, the domain and the range, and how we solve them. All right, so those are just a couple of examples of how to solve for the domains analytically. And again, we'll get into this more tomorrow as we look at some graphs.